Tina slowly. We be working all day long, the push us bunny. We ain't playing no games. Sabatavi, Gani.
Hello everyone. Hello grade 11. I hope that you are good and you are ready for this chapter again. We are still busy with chapter 1, exponents and sets. So we are going to do this question. So here we're given root cube root x equals to 12 root x. So we have the left and the right hand side. So which means I have to prove the left and the right hand side if they are equal. So guys, here if I'm working with this, I need to remember my root definition. Remember your root definition we said on the previous video. If it is n root and a here to the power m, if I'm writing this in exponential form or radical form, it is the same as a to the power m over n. So this is what you are going to need in this question. So I'm going to consider this one as my right hand side and this one as my left hand side. Understand? So I'm going to cut this paper into this half. So I'm going to take my right hand side and simplify it and write it in radical exponent. In rational exponent. So I'm going to have 12 root x here. Remember the power of x here is what? It's 1. So this thing is the same as x to 1 over 12. So whatever that I get here must be the same with this one if it is written in a rational exponent. So if I'm taking the left hand side, guys, here I have 2 here and I have 2 here. So which means I'm going to change the first one. So I'm going to keep the larger exponent and keep the cube root. Then I change this one to be x, which is raised by 1 over 2. Understand? Because we said in the previous video that half is equal to the power is equal to the root. If I have x to the power 1 over 2, this thing is the same as square root of x. Understand? So then we come here and change this one. So guys, if we change this one, I'm going to do it aside because we are going to take this denominator, which is half over 2 divided by what? By 3. Because this one will become your numerator and this one becomes a denominator. So I'm going to divide half divided by 3. So if I say half divided by 3, which is the same as 1 over 2 times, because we changed this one to become 1 over 3. So 1 times 1 we get what? 1. 2 times 3 we get what? 6. So in this case now, inside the larger root, I have x to the power 1 over 6. Now we are left now with one step. We already know that we have 2 here again. So which means it's the same as if I'm going to say 1 over 6 divided by what? By 2. Remember, I'm going to apply here reciprocal. So I'm going to have 1 over 6 times by 1 over 2. So 1 times 1, you get 1. 2 times 6, or 6 times 2, you get what? 12, which is the same as this power. Okay. So this one, guys, is going to change to become what? Your x to be 1 over 12. So if you are writing it in exponent in set form, it's the same as square root of x inside your base. Then this is your nth root here. Then you have 1 here, which is the same as this one. Now you can conclude that your left hand side here is equals to the what? To the right hand side. Right. So let's move to the next question. So the next question here, we are given this one. So they say that write this root 3 times cube root 2 in this form. Okay, so what must I do here? So I'm given this, guys. I must write it in this form, which is a to the power b, a root b, ne? So I want to write it in this form. So we all know that, guys, here I have root 3. What I have here, we know that, guys, I have 2 here, I have 1 here. So then times by cube root 2, then I have 1 here again. So if I write them in exponential form, it's going to be 3 to 1 over 2 times 2, then it's 1 over 3. So the only thing that is left for us is to make here, because it's tricky here, because the bases are not the same, so I'm not going to apply the laws of exponents. And also, if I make the denominators of the exponents to be the same, it will work for me. So can you see that, guys? 2 and 3, they are factors of 6. So which means that if I say here 3 to be 3 over 6, we know that, guys, 3 over 6 will still give us half. Then if I want to get again 1 over 3, which means is the same as 2, I'm going to say here 2 over 6. We all know that, guys, 3 over 2 will still give us 1 over 2, and 2 over 6 will still give us 1 over 3. So I'm trying to make the denominators of the exponents to be the same. So if I say here for 3, then I apply law number 3, your laws of exponents. Then I take out 1 to the power 1 over 2, 1 over 6. If I say here 1 over 6, so then I will make the power to be what? To be 3. Because if I multiply again, 3 times 1 over 6, you still get 1 over 2. Then times, so here, what we'll have inside? Yes, we'll have a 2. So then I have outside 1 over 6. So are we together? So now, can you see that here, guys? The exponents are the same. So I'm going to take one exponent outside, then I multiply the bases. That law, if I have 2x times 3 to the power x, the exponents now are the same. So I'm going to take one exponent outside, then I say 2 times 3, which is in this case is 10 to the power x. So that's what we are going to do here. Our power now is 1 over 6. So I'm going to have inside 3 to the power 3 times 2 to the power 2. So now you all agree with me that 3 to the power 3 we get what? 27. Then 2 to the power 2 we get what? 4. Then we apply body mass. So if we apply body mass, guys, 27 times 4, what do you get? You get 108 to the power 1 over 6. Remember, we can write this in root form. So we know that root form, guys, we said if we have n to the power a to the m is the same as a to m over n. So this one is written in what? In rational exponent. So I'm going to have root here because I want to write it, because I was instructed that write this in this form. So I want to write it in this form, guys. So I'm going to say this is 108. Then remember, this one was your root here. I have 6 outside, then I have 1 inside. So in this case now, we know that your a will be 6 because they say write this in this form. So now we can conclude that your a here will be 6 and your b will be 108. So bear in mind, guys, they didn't say solve for a and b, but they said write this in this form. So this is the form they want. So it's just that we are giving them the values of a. So here we have a, which is 6, and b, which is 108. All right, so let's move to the next question and see what we have. So we are still simplifying, guys, the sets. So this question we are given root 48 minus root 3 over root 27. Remember, guys, if I'm given the roots, what must I do? We all know that, guys, when you're working with roots, under the root, this is the set, so you must have a perfect number, or you can say a perfect square times prime number. So we can see that, guys, 48 is not a prime number, so I have to change it and find the perfect square and the prime number. So what do you do to find them? So you are going to say, guys, as it is, you are going to press it on your calculator like this. You see, you get what? You get 4 root 2. I mean 4 root 3. So if you get this, they will say without use of a calculator. So remember the laws of sets that we said on the previous video. So I'm going to put squared here because I see that it was a perfect square. Because if you can take maybe 13, for argument's sake, if you say square root of 13, can you see? So this one, it's irrational. So here, guys, if I put 4 squared here, then I bring it inside, 4 squared will give me 16 times these 3. So if I apply law number 1, laws of sets, which is a multiplication, this is the same as root 16 times root 3. Now, can you agree with me that root 16 will give me 4 root 3? So that's why your calculator gives you this answer. So here, guys, I'm going to change this one to have root 16 times 3 minus, can you see that, guys, here? Root 3 is already a prime number, so I'm not going to stress myself with root 3. So I'm going to keep root 3 as it is. So what happens to 27? So if you press root 27, what do you get? You get 3 root 3. Then you put squared to this 3 outside, you get what? 9. So which means inside, what do you have? You have 9 times 3. Understand? Then you apply laws of sets, which is law number 1, law 1, which is multiplication. So I'm going to have root 16 times root 3 minus root 3 again over here root 9 times root 3. Okay, so guys, root 16, what does root 16 give us? Give us 4 times root 3 minus root 3 over, this is becomes, the root 9 becomes 3 root 3. Okay, so guys, you have, consider this part as 4x minus x. So 4x minus x give us what? Will give us 3x. So this thing is the same as this one. So I'm going to say 4 root 3 minus root 3. So you're going to get 3 root 3 over 3 root 3. Wow, now we're close to the answer. So root 3 divided by root 3, what do you get? Yes, it's 1. That is the final answer. Remember, guys, you can press this one on your calculator and check what you want. If you say root 48 minus root 3 divided by root 27, can you see your answer was 1? Which means whatever you are working, they didn't mean when say without use of a calculator, just put your calculator away from you. You can use your calculator, but you must make sure that you hide the steps where you are using your calculator. Here, we used our calculator to get the prime factor, the prime number, and the perfect square. But I didn't take it to this step because your calculator, if you press root 48, it will give you 4 root 3. So you need to be careful. This is easy. Just take this hint. It's a perfect square times prime number. Then you will be fine. You will be fine. There's nothing will trick you. So let's take the next question similar to this one we just did here. So guys, we are simplifying again here. We have root 48 minus root 32 all over root 12 minus root 8. Okay, So guys, if I'm simplifying this, I need, again, you must make a note here. I need what under the square root? I need a perfect number or a perfect square times a prime number. Okay, we know that, guys. Here we have root 48. I will say again, root 48. Do you see I get what? I get 4 root 2. I get 4 root 3. Then I will put the squared to this 4 outside. What will you get? You will get 16, which means inside the root you have 16 times what? 3. So are we together? So inside the root I have what? 16 times 3. So minus, then we have 32. So if I have root 32, I'm going to do like this. I have 4 root 2. So I'm going to put squared with this 4. I get 16 times 2. So which means I will have inside 16 times 2. I hope, guys, you are following. Then I have root 12. So for root 12, if you press your calculator, then you get what? 2 root 3. So then you put a squared with this 2. Then you get 4 times 3. So if I come here, then I get 4 times 3. Then for 8, guys, I'm going to get a 4 times 2. Guys, if you didn't watch my first video where we were explaining the laws of sets, please go and watch the first video so that everything will be clear to you. So here, guys, we are breaking this one, applying law number 1. So I'm going to have root 16 times root 3 minus root 16 times root 2 all over root 2, root 4 times root 3. Then here minus root 4 times root 2. Okay, so root 16 gives us what, guys? Give you 4. 4 times root 3 is 4 root 3. So root 16 again give you 4, then 4 times root 2, root 2. So 4 again, guys, give you what? 2 root 3. Root 4 times root 2 gives you what, guys? Negative 2 root 2. Now, can you see that, guys? This will not cancel this, and this will not cancel. Remember, whenever you have two terms, and here, whatever that we have under the root is not the same. So, we cannot consider this one as x minus x. We can consider as 4x minus 4y. So, what is common here, guys? Yes, it's 4. So, here, the common factor, let's put an equal sign. So here the common factor is what? It's 4. Then I'm left with what? With root 3 minus root 2. Okay. So then on the denominator we have 2 root 3 minus 2 root 2. Okay. So we can consider this one again as 2x minus 2y. So now ask yourself, what is common here? 2 is common, we can see. So now I'm going to take out 2 outside, then I have root 3 minus root 2. So what will happen, guys, with these terms that we have on the brackets, in the brackets? So this is going to cancel out this one. Now you have 4 divided by 2. What do you get? You get 2 as your final answer. So are we together? Yes, guys, I hope that you do understand. So guys, this is our last question. So like they say, simplify this. So if you are simplifying this, guys, remember we have two sets of brackets here, and inside the brackets we have the square root. Remember, if I have square root a times square root b, can you see that the square root here is the same with this one? I'm going to take one square root and multiply what I have inside, which means I'm going to say a times b. So same applies if I have square root of 3 times square root of 7. So the square roots are the same, so I'm going to take one square root and multiply what I have inside, which is, this case is root 21. So what we need to do here, guys, so it's simple. I'm going to take one square root as you can see that this square root, guys, is the same with this square root. So are we together? So I'm going to take 1 square root and multiply what I have inside. So inside I'm going to open brackets because I have binomial. I have root 13 minus 2 and root 13 plus 2. I hope that you can see that this is a difference of 2 squares that we have inside. So I'm going to keep the larger root here. Now I'm going to say root 13 times root 13, guys. So root 13 times root 13 will give us 13. Then root 13 times 2 will give us positive 2 root 13. Then negative 2 times root 13, what we'll get? We'll get a negative 2 root 13. Then we have negative times a positive, that's a negative. Then 2 times 2, we get 4. Yes, so what will happen to 2 root 13 and minus root 13, 2 root 13, so this one gonna cancel out. So now we have left with root what? Then if I say 13 minus 9, I saw 13 minus 4, what do we get? 13 minus 4, we get 9. So we know that 9 is a perfect square. So in other words, this is root, and so we always have 2 here if it is not written that degree here. So we know that 9 is made of 3 to the power 2. So this will cancel this, guys. Now you are left with what? With 3 as your final answer. So this is your final answer, guys. Thanks for watching. If you didn't subscribe, please don't forget to subscribe. Like the video. Tell us how do you feel about our lesson. See you on the next video. Thank you.